Hi friends, good morning one and all. Myself Bhausab Sononi, Assistant Professor, Department of Chemistry. Dear friends, in the previous lecture, we discussed about some basic terms of nuclear chemistry. We discussed about mass number, atomic number, which are very essential to describe the nucleus of particular element. With the help of these terms, we also try to define the subatomic particles, and with the subatomic particles, we studied the concept of mass defect. We also learned that in the previous lecture, if any nucleus is unstable, then it emits radiation spontaneously in order to achieve stability. And this phenomenon, this process is called like the radioactive disintegration, and the phenomenon is called like radioactivity, and such elements are called like the radioactive element. So today, in this part of the lecture, we are going to define the phenomenon of radioactivity. But before discussing the radioactivity, we are interested to discuss some discovery of radioactivity in which the contribution is given by different scientists. The first attempt, actually, it is made by Wilhelm Röntgen in the year of 1895. What happens actually? He observed that when the electrons bombarded on the surface of certain materials, then these materials emits some rays, invisible rays, and these rays were responsible for the darkening of photographic plate. So these rays which was responsible for the darkening of this photographic plate were named as X-rays by Wilhelm Röntgen. After Wilhelm, the next attempt is made by another scientist called as Henry Becquerel. What he has done actually, he has taken a particular sample containing uranium salts, and he found that this uranium salt or the sample of the uranium salts emit light whenever exposed to sunlight. And again he observed the same observation, that these rays which was emitted by the salt of uranium element or the uranium atom, again responsible for the darkening of photographic plate. So here in this picture you can see, so this is the sample containing salt of uranium atom, and this is the photographic plate which becomes darkened due to the radiations emitted by the sample of minerals of uranium salts. So here, till this, Henry Becquerel didn't had any idea which elements in this sample was responsible for the emission of this radiation, which was responsible for the darkening of this photographic plate. So here, with this, the next attempt is made by another scientist, Marie Curie, and her husband Pierre Curie. What they had done actually, they took the Becquerel sample containing again uranium atoms, and they tried to isolate the components which was emitting the rays from this sample, and again they found that the rays which was emitted from this sample were responsible for the darkening of this photographic plate. But in this attempt, they have made quite different thing, is that they tried to isolate the components which was responsible for the emission of rays, and they came to know that a particular atoms was responsible for the emission of rays, and these atoms was uranium atoms. So here in the minerals or in the sample of minerals of uranium salt, a particular atom was responsible for the emission of light or the emission of rays, and these atoms were found to be uranium atoms. So they tried to isolate these atoms, and they came to that not all the components, but actually only the uranium atoms present in this sample or present in these minerals were responsible to emit the rays, to emit the radiation. So here this is the one of the most important and successful observation made by means of this Marie Curie and Pierre Curie, her husband. And this Marie Curie named this process by which materials emit such type of the radiations spontaneously as radioactivity, and the rays or particles emitted by such a radioactive element or the radioactive source as radiation. So radiations are the rays emitted by radioactive element, and the phenomenon of emission of such radiation by the radioactive element is called as the radioactivity. Radioactivity is the phenomenon, and the process is called as the radioactive disintegration. So radioactive disintegration is the process, and the phenomenon is called as radioactivity. But both process as well as phenomenon both leads to the formation of stable nucleus from unstable nucleus. So here this spontaneous emission of rays is only because of the instability of the nucleus, and that unstable nucleus tries to attain a stability through the phenomenon called as radioactivity. So here this is regarding the discovery of radioactivity of the nucleus of the atom. So here with this discussion we can define the phenomenon of radioactivity. So radioactivity is spontaneous disintegration. So for that purpose we are not requiring any external agency, external force or external energy, but this is the spontaneous disintegration of unstable nucleus. Already I told you, those nucleus of the element which are unstable, they always tries to attain the stability, and for that purpose they emit the radiation spontaneously. So here spontaneous disintegration of unstable nucleus with the emission of radiation that can affect photographic plate, because in the previous part or the previous slides we discussed that the radiations which was emitted from this radioactive element of the radioactive material was responsible for the darkening of the photographic plate, and that's why these radiations are highly energetic radiations, and therefore these radiations can affect the photographic plate, and these are also having some penetrating power. So these are responsible to penetrate the materials which are opaque to ordinary light. So this is the definition of radioactivity, is that the spontaneous disintegration of unstable nucleus with the emission of radiation that can affect photographic plate, and also penetrate materials which are opaque to ordinary light. Or simply we can define the radioactivity is the spontaneous emission of radiation or the emission of radiation spontaneously by unstable nucleus of atom which can affect photographic plate and penetrate the material which are opaque to ordinary light. So in short we can say that spontaneous emission of radiation by unstable nuclides called as radioactivity. So what are the types of radiations emitted by this radioactive element? This is also one of the again important thing. So generally isotopes are the atoms having the same atomic number but different mass number. It means that these are the elements which are having the same number of protons but different number of neutrons. And isotopes of atoms with unstable nuclei are called as radioisotopes, and these radioisotopes are responsible for the emission of different types of the radiation. So what type of the radiations are emitted by radioisotopes, that we will discuss in the next slides. But this emission of radiation is responsible to attain the more stable atomic configuration. So already I told you, those nucleus which are very unstable always tries to attain stability through the phenomenon called as radioactivity, through the process called as radioactive disintegration. That's why I told you unstable nucleus always emit the radiation to attain a stable atomic configuration through the process or in a process called as radioactive decay. Radioactive decay is not different from radioactive disintegration. Decay and disintegration both are the same, both are responsible for the decreasing mass, and that's why. So this is because of instability of the nucleus, and definitely after radioactive decay the unstable nucleus becomes stable, and during this process, during this phenomenon, this unstable nucleus loses its excess energy by emitting a different type of the radiation. So this here, what type of the radiations are emitted? Definitely the radiations emitted by any unstable nucleus depends upon the number of protons and number of neutron present in the nucleus. So here some types of the radioactive decay we can show here. The first radioactive decay is alpha decay, in which n by z ratio or ns to z ratio increases. N is nothing but number of neutron and z is the number of proton, so called as alpha decay. So in this type of the decay, in this type of the radiations or the emission, in this type of the emission, definitely there is a conversion of unstable nucleus into stable nucleus. What happens actually in this process, if you observe here, so this is the first decay called as alpha decay. We will discuss later on about this. Next one is called as the beta decay. So, and the last one is called as the gamma decay. Actually, in this type of the process, in these three types of the process, so this is the one nucleus is having the mass number A and the atomic number Z. What happens after this alpha decay? After this alpha decay, this unstable nucleus, this is the unstable nucleus, it will be converted into stable nucleus. But with this conversion, the atomic number of newly formed element that we can call a daughter element is decreased by 2, while its mass number is also decreased by 2, and this emission is called as alpha emission, or it is also called alpha decay, because this particle is called as alpha particle having mass number 4 and the atomic number 2. This sometimes is also called as the helium nucleus, because it is having the atomic number 2 which is equivalent to the helium, and the mass number will be 4. The second type of the decay or the emission is called as the beta decay. It is also called as the beta emission, in which number of neutron to proton ratio decreases. In this case, suppose this is the parent nucleus, so it will subject for the beta decay, beta emission. So it will emit some particles, in which what happens, the atomic number is increased by 1 while mass number becomes unchanged. So this is the case, and there is an emission of particle. That particles are called as the beta particle, so it is also called as the electron. And the third type of the decay is called as the gamma decay, in which the element, that is both parent as well as daughter element, will have the same mass number and the atomic number. So there is no change in the atomic number and the mass number of both parent as well as daughter element. So in this gamma decay, there is only emission of gamma radiations. That's why this type of the decay, this type of the disintegration is called as the gamma decay. So these are the three types of the decay of radioactive element. These types are based upon the type of particles emitted by radioactive element. So this slide shows this indicates the penetrating power, because in the definition we discussed that this rays emitted by the radioactive element is having some penetrating power. So we can come to that alpha radiations are having very low penetrating power, while gamma radiations or the X-rays are having very high penetrating power, and neutron will having the highest penetrating power. So this is the trends of increasing penetrating power of different types of the radiations emitted by radioactive element. Thank you. So we will continue in the next slides, in the next part of the lecture, to discuss